Hello champs, welcome back to the day 6 of the 100 days of hell with Python algo trading. This is around 3:30 a.m. in Singapore and chasing some dreams. And if you are also feeling low, sometimes depressed also, please stay consistent. We'll go through it. This is just day 6. I'm still very confident that we will be able to achieve this target no matter what happens, and for that I need to work harder. So let's get started. Today we will be covering the sets and dictionaries, and then we will perform some examples, and then you know what you have to do. You have to attempt the MCQs, multiple choice questions, then task, and then mini project. So yeah, that's the plan. So let's get started without a further ado. So first of all, we understand some theory of sets. So a set is an unordered collection of items. So pay attention to these words. Every set element is unique and must be immutable, right? However, a set itself is mutable. We can add or remove items from it. Sets can also be used to perform mathematical set operations like union, intersection, symmetric difference, and many more. Then we have few characteristics that sets are unordered. These are mutable, no duplicates, and can't contain mutable data types. So let's take an example. For example, we have a set A. So how do we represent sets? With a curly braces, correct? So let's say we have 4 stocks in that set. So Apple, then we have Google, then we have Tesla. Okay, let's make it 3 only. And in set B, we have, let's say, Tesla, then Amazon, and then we have Microsoft, correct? So let's create some Venn diagrams. Okay, for example, we have a set A, then we have the set B, right? So here we will write the set elements. So in set A, I'll represent this with A. In set A, we have Apple, so I'll just write the first letter. Then we have Google, right? And another we have is Tesla, correct? Then in set B, we have Tesla. So Tesla is also in this set B, so I'll just leave it. And we have Amazon. So I have to write, let's say, AM to differentiate. And then we have the Microsoft, correct? Here we can see that this is set A, which have Apple, Google, and Tesla. This is set B, which consists of elements Tesla, Amazon, and Microsoft. So now basically we have 4 operations on this. So first is union. The first is union. We have first operation, which is union. That means we combine all the elements from set A and set B and create a new union set. So how we can do that? Let's say we have AGT. So let me create a union set. So I'll just represent this with U is equals to a new set, which consists of Apple, then Google, correct? Then we have Tesla, then Amazon. So Amazon I'll represent with red, and the last is Microsoft, right? Now pay attention here. See, these elements are from the set A, correct? And these elements are from set B, correct? As we have already seen that sets do not have duplicates. Even if there are duplicates, it will get ignored, right? So the Tesla was duplicate here, so it was ignored. And in the union of sets, we have these 1, 2, 3, 4, 5 elements, correct? So in short, you can say union is the combination of all the elements from both the sets, and you can ignore the duplicates. So that simple the union is, right? So the next is intersection. Intersection is very easy. You just have to consider the common elements. So here we can clearly see that we have only one common, that is Tesla, correct? Only this area. So what we can do, I'll just go ahead and write a new set intersection, and it will be only Tesla. So I'll just write here second, which is intersection. Correct. Next we have is difference. Difference is also, as the name suggests, we just take the difference of the elements. So let's say if we are taking the difference of like A minus B. So in difference, first of all, we will check that if there is any common element. If yes, then just remove that. And then you check what are the remaining elements in the set A. For example, if I did A difference B, then I know that T is the common element. Just remove that. We are left with Amazon and Google. So I can write a new set. In that we have Amazon and Google. Correct. If I write B difference A, B minus A, then again we will remove the common element, which is Tesla, and we are left with Amazon and Microsoft. It was Apple here in the A negative B, right? This was Apple. So I can write Apple. And when we perform B difference A, we will ignore this T element and we are left with Amazon and Microsoft. So MSFT. That's the basic idea of difference. Next we have is also very easy. That is symmetric difference, right? So we can write like symmetric difference. So in symmetric difference, what you do, you just ignore the common elements and then you write all the remaining elements. So here, when we check that Tesla is the common, so we ignore that and we are left with Apple, Google, Amazon, and Microsoft. So we'll write A, symmetric difference B, and then we will write the remaining elements, which is Apple. Then we have Google and Amazon, and we have the Microsoft. So that is the symmetric difference. So now we have few more properties, like if someone asks is disjoint. So in disjoint set, what happens? If there are no common elements, then we can say yes, true, right? But we know that this set is false. So if we have a question whether these sets are disjoint, so we will say false. Correct? A Boolean value false. We have another property which is its subset. So when we have is as prefix, we just have to think in terms of true and false. So when it is asked that is subset, in that what happens, like we have two sets. First is Apple, second element is Google, correct? Then the second set we have is Apple, Google, then let's say Amazon. Correct? So if someone asks whether A is subset of B, then we can say true. Why? Because all the elements of set A are existing in set B, right? Next we have superset. So if we have a question is superset, so similarly, if someone asks B is superset of A, then we can say true. Why? Because of all the elements of A are existing in B, correct? So it's very easy. Yeah, we can say that B is the superset of A. Similarly, next we have unique. So is unique. In this what happens? For example, we have this set B. So I'll just add another element in this, and let's say this is Apple. If now someone asks if B is unique, then we can say it is false because it is not unique. It contains the Apple element. So when we have duplicates, we can say that that particular set is not unique. So with that being said, that is the basic theory of sets, and I hope that you understood it very well. And if you still have any doubt, you can connect with us. Now we quickly perform some examples and then we'll proceed with the dictionaries. Now we quickly perform some examples so it will be better for understanding. So let's say we want to create an empty set. For that you have to write the word set and then you can leave it. So when you hit shift enter and when you print s1, you can see that we have a set and then the parentheses, right? And when you check the type of this, you can also see that this is from the class set. So we know that this is the set, right? Then again the same 1D and 2D sets. So for 1D sets it is same like the list and tuples. For 1D sets you only have one curly braces. So when you, I'll just comment these out. So okay, so when you print this, so when you print s1, you get the elements from the set s1. And for 2D sets, what you can do, you can like just have a set inside a set, right? So I can write like this and then I'll give some elements inside that set. So it can be msft and then we can write meta also, correct? So you just pause the video and you let me know whether this will work or not. Okay, so when I hit shift enter, let me comment these out, and when I hit shift enter it says unhashable type set because we have already seen that it cannot contain mutable data types, right? But we know that a set itself is mutable, so we cannot have a set inside set. So instead of this you can have a tuple, right? And when you print that out, let me print the s1 and you will be having the elements. And here you can also observe another property of sets, that here we had the order like Apple, Google, Tesla and then another tuple, but here when we print out we get the tuples first, so there is no sequence. So we can say the order doesn't matter here, which was another property of sets. See here it is unordered, right? So which element will come first we do not know, it's completely depends on the hashing. Then we have another properties which is a homogeneous or heterogeneous sets, which we have already seen in previously in list and tuples. So it's same. So you let me know whether this set is homogeneous or heterogeneous. Let me comment this above. So we know that we have 4 elements. The first 3 are strings and this 4th one is tuples. So we can say that this is heterogeneous. But if you wanted to make it, first let me print this s1. I'll print s1. Okay, so when we print it we get this value, right? Again the order has been changed, the sequence has been changed. And now when I want the homogeneous, what we can do, I'll just write s2 here and I'll give it s2 also. Okay, so here I'll just remove the tuples. Okay, and now all elements become strings, and when I print this I get 1 2 3 4 5. I get the 5 elements, which is true, and these all are strings. So we can say this is homogeneous set and this is heterogeneous set. Next we have using type conversion. For example, we have a string, so let's say this is s3 equals to apple, correct? And we can also print it out. So I'll just copy and paste here and make it s3. Okay, and I will also again print the type of this. So let's say type. So and we can comment the above ones. Okay, when you perform the examples you can remove the comment and you can proceed. So now when I print this, we can get the output like the s3 is apple and class is string, but we want to make it a set with the help of type conversion. So what we can do, we can simply write here the set, right? And when we hit shift enter, you can see that the string apple has been splitted into multiple elements, and we have got a new set with 3 elements. And because these 2 AA were duplicates, so it just gave us a single element. So we have converted a string to a set, you can see here. And the second one is duplicates are not allowed, which is true because we have 2 A's here and that is not allowed in sets, so it will ignore the second one, correct? Again, set can't have mutable items, as I already mentioned and explained here, that we cannot have a list or a set itself here. So let's again check it. I'll just comment it. When I print here, now we have the output of set, which is okay. But if I change it to a list, let's say I change it to a list, this element, and when I hit shift enter, we get the error unhashable type. And even if you make it set, it will not work. So I'll just convert it to a set, and when I hit shift enter, the same error we face. So these are the basic properties. Now let's move to some operations, like how to access the set elements. So as we know that when there is no order, the elements are unordered, then we cannot assign any index to them, right? So accessing by index doesn't make sense here. Then how we can access the elements of any set? Then we have a question that if we cannot assign any index, then how we can access the set elements? So there are a few other ways, like you can convert a set to a list. We can access it by like iterating, and we can also access the elements by iterating. So let's see all the other methods. So for example, if I try to access the set elements with the index, so let's say I give t2 0. So of course it will throw an error. You can say set object is not subscriptable. So similarly, we have editing items. So in editing also, when we don't have the index, it becomes difficult, right? So let's say if I write same t1 is equals to, let's assign it Ethereum, right, t2. So when we hit shift enter, it throws the same error. The set object doesn't support the item assignment. But we know that the sets are mutable, so we can add or remove the values. So how we can do that? For example, if you want to add something to a set, so what you can do, you can just write t2, the name of the set, then add. And here, if you write like eth and a string, and when you print t2, you will get the value, right, eth. So with the help of add, you can add. We have another function which is t2.update. So update, and you can add eth. So, and again, when you print t2, you will get eht. So if you remember, in list we have seen two functions, append and extend. So similarly, the same thing is happening here. The append is equals to add. It will only add one value, but update always try to add multiple elements. So even if you passing here a single string, it is splitting that string into multiple elements and it is adding. So for single element, you have to use the add function, and for multiple elements, you have to use the update function. So here what I'll do, I'll just make it a, let's say, a list. Then I can give like eth and btc, and let's say xrp, correct? Okay, now let's hit shift enter here. So you can see that we have btc, eth, xrp, and of course the property of sets that it will ignore the duplicate values. So it has ignored the btc and eth, correct? So this is how we can add items in a set. Now we have the next topic, that is deleting items. So for deletion, if you want, you can delete the whole set. So like we have this set here, and let me first print it. So t2, we can see that we have the set elements, and if I delete it, del t2, and again print it out, then it will throw an error that t2 is not defined, right, because it has been deleted. And similarly, as there is no index, you cannot delete any single element with the help of indexing, right? So if you try to do that, it will throw an error again that set object doesn't support the item deletion. Item you cannot delete, you can delete the whole set. So now we have the next function, discard and remove. So for example, if I use the discard function here and I write that 50. So in discard, what happens, as we know that we don't have any index, so we have to write the value, the item value. So here, if I write s.discard, let me make it t2 because the name of set is t2. So if I discard 50 from the set, and when I hit shift enter, it doesn't display any output, and I can print the t2 again here, and we have, now you tell me that why we do not have the true as output here. Okay, that is a question of the day. and you just go and pause the video, you check the answer, and you let me know in the comments that why the true boolean value is not displaying here. Okay, so now we check this one. When we try to delete the value 50 from this set, it will not display anything and it will not display any error, right? But if we use remove and same 50 and I would try to print T2 again, so it will throw an error. So the main difference between discard and removes is that discard doesn't throw any error when the element is not existing in the set, but remove will throw an error if the element is not existing in the set. Otherwise, both perform the same operation, correct? So what you can do, you can check that I will remove the BTC with the discard and I will remove the 1.5 with the remove. So when I hit shift enter, we are just left with the 1, right? So because discard remove the BTC and remove the 1.5, and we know that we have this 1 and true, but I don't know why we are getting the error that I'm only getting 1. So it's your question, it's your challenge that you have to let me know why the true wasn't displayed here. Okay, now let's move to the next topic, which is, let me copy and paste these here, S1 and S2. I'll just comment these out, and what we can do, we can add this S1 and we can have another S2. So in that, what we will do, we will, let's leave the Tesla and we add another values like Microsoft, and we can add Meta, correct? So here we can say that in S we have 3 elements, Apple, Google and Tesla, and in S2 we have Apple, Google, Tesla, Microsoft and Meta. So as we have already understood these topics in the starting of this video, so if you are having a little bit confusion here, you can just go back and watch the video and come back. It will be very easy for you. Okay, so for union, so what we will do, so in union we can perform with the 2 ways. One is we can have this pipe, so it also represents the union in the sets. So when I hit shift enter, it will give me the union of both the sets, S1 and S2. So you can see that we have Apple, Google, then Meta, then Microsoft and Tesla. Okay, and now you can see that we have 3 plus 5, 8 elements, but we are only displaying 5 elements. Why? Because the first property, we cannot have duplicates, so it ignored these 3 duplicates. Okay, only one time it printed out. Then the next is unordered, so there is no order, it will display in any order the Python wants. Okay, next we have the intersection. So you know that in intersection it displays only the common elements. So when we hit shift enter, it will give us the Apple, Google and Tesla as per the Venn diagram we have seen previously. Now we have the difference, so S1 minus S2. So from S1 it will remove the common element and it will display the S1 minus S2. So here you pause the video and you comment down the answer that what will be the S1 difference S2. So when I hit shift enter, I get an empty set because these 3 elements were common in both the sets and it removed all the 3 common elements and we are left with an empty set. Similarly, when we perform that S1 minus S2, so what it will do, it will remove these 3 elements and we are left with Microsoft and Meta. So when we hit shift enter, we get as Meta and Microsoft, right, in like unordered sequence. Then we have the symmetric difference. So in that, what it does, it will take the common and it will remove the common items and it will display the leftover elements of both the sets. So when we hit shift enter with the symmetric difference, you can use this sign here, arrow, upper arrow, and when you hit shift enter, you can see that these 3 were the common elements, right, and we are left with only Microsoft and Meta. So that is the symmetric difference. Then we have the membership test. So it's also the same, the in and not in. If the element is existing in set, then it will print out that it is true, and if not, then it will print out that it is false. So it's very simple. We can say that whether let's say Apple, and I'll print not in S1. So when I hit shift enter, we get false because Apple is existing in S1. But I just makes a spelling mistake. Let's say Apple. So when I hit shift enter, it will give me a true answer, right? And when I check for in, so Apple in S1, it will false. It will be false, right? So you can see here. Now we have the loops. So you can access the elements of any set with loops also. When I write like for I in S1 and print I, so it will print out all the elements of set Apple, Google and Tesla. So these were the basic operations of set. Now we move to the next, which is set functions. This is also exactly the same, the len, sum, min, max, sorted, which we have already learned in list and tuples, right? So let's say we have a set which contains these values and we want to find out the length of this. So of course it will check the length, which is 1, 2, 3, 4, 5, 6, and it will print out that length, so which is 6, right? Then we check the sum of this, so it will sum all these values and print out the answer. Next we have minimum, so of course it will give us 1 because that is the minimum value. Next we have max, so it will check which is the maximum number in the set, so it will output 7. And similarly we have sorted, which is also the same. So when we hit shift enter, it will sort the values and it will make reverse as true, so it will sort in descending order 7, 5, 4, 3, 2, 1. Now as we have already seen the union, intersection and difference and symmetric difference with the help of Venn diagrams, so these will be very easier. So let's say I want to, let's copy and paste the earlier sets here. So S1 and S2, here we have the S1 and S2. So if I want the union of S1 and S2, so when we hit shift enter, it will give us these values, of course. But if I want to update it permanently, so what you can do, you can just write as, let me print it here below, and I will write update, correct? And when I hit shift enter, okay, so as there is no output, and we have discussed this already multiple times, that when there is no output in Python, it means that that value has been changed permanently, right? So when I check the S1, you can see that the value of S1 has been changed from Apple, Google, Tesla to Apple, Google, Meta, Microsoft and Meta, which is the union of both the sets. So that is the difference between union and update. If you just want to see the value, you apply union, but if you want to see the updated union value in any set, you write like update. You have to use the function update. Similarly, you can even perform this also, S2, S1. So then the changes will be made in S2, not the S1. So when you write shift enter and then you print S2, you can see that this is the updated set. So here there is no changes because S2 was the superset of S1. So we'll just discuss what is a superset. What we can do here, we can add another, let's say BTC, okay? So now when we check, we can see that we have another element which is BTC. So that's the difference between union and update. Similarly, we have intersection, that is also exactly same. So if I want the intersection of S1 over S2, so it will just print out the common values of S1 and S2. So we will get Apple, Google and Tesla. And if you want to make the changes permanently, so what you can do, you can write intersection update and S2. When you hit shift enter, there is no output, means you know very well. So when I check S1 again, you can see that it has been changed from Apple, Google, Tesla, BTC to Apple, Google and Tesla, and that is the intersection update. Similarly, difference and difference update. So I'll first check the S1 difference. We get the BTC because when we check that we have subtracted the common values and we are left with only BTC. Similarly, you can check the S2, S1, and you will be left with MSFT and Meta, correct? And if you want to make the changes permanently, what you can do, you can use the difference update and S1. So when you hit shift enter, you will be left with nothing. Why? Because you will be definitely left. You have to print the S2. So when you print S2, the common values has been removed and you are left with only Meta and Microsoft. Similarly, we have the symmetric difference. That's we have seen already with the help of Venn diagram. So when you perform the symmetric difference, so what you can do, you can write like S1 dot symmetric difference over S2. So you can see that we have BTC, Meta and Microsoft, BTC, Meta and Microsoft. So what it will do, it will remove the common values and then it will give the remaining elements from both the sets. And similarly, same, if you want to make the changes permanently, you just have to write symmetric difference update and S2 and we'll get no output. So for that we have to print S2 and and you can see that, okay, we have to print S1, and you can see that we have meta, MSFT and BTC, correct? Then we have few Boolean functions. So is disjoint, is subset, or is superset? So if we check, S1 is disjoint of S2, means if there is no common value, it will be true, otherwise it will be false. So here it will give us false. Of course, S1 is subset of S2. So if we check is subset, and when we hit enter, it will be, you let me know in the comments, pause the video. So when I hit shift enter, we get false because this BTC is not existing in S2. So when we remove this BTC and when we hit shift enter, we can see that S1 is the subset of S2, correct? Then again superset. Superset is also very easy. So when we check that is superset, so S1 is not the superset, but we know that S2 is the superset of S1. So when we check, we have the true answer, right? That's very easy. Just perform some multiple choice questions, then you go for the task and the mini project, and you will be good to go forever. Next we have the copy function. So copy is also the same exactly which we have seen in list. So when you do not want to make the changes in the original set, you can make another copy of that set, and then you can perform the operations. So what we can write like S1 dot copy, and if you want, you can assign it to S3, right? S3 equals to copy. So when you check the values of S1 and values of S3, you can see that you have exactly the same, but the difference is that the memory address of both the S1 and S3 is different. So you can check that with the function ID, right? ID, and here also we will check with the ID. And when you hit shift enter, you can see that it is at 32 and it is at 80. So you can use it also sometimes, it is useful. Next we have Frozenset. So the Frozenset is just an immutable version of a Python set object. Means we know that the sets are mutable, but sometimes we want the mutable set. So we call that as a Frozenset. So we have here fs1 equals to Frozenset 1 2 3 and fs2 equals to Frozenset 3 4 5. So when we perform a union on this, so we will get the value as 1 2 3 4 5, correct, which is true for the sets. So what we can say here, that all the read functions will work, but any write operation will not work here. So what were the write operations here? So if we try to update this, so fs1 intersection update, you can see that there is no function like that in the Frozenset. Even in update also we cannot use here. And let's say we have difference, so difference also we only have the difference but no update, which we have seen previously. So we cannot write anything here, we can just read, and it's also very useful sometimes. So, and definitely you'll be using it in future. Okay, so please attempt some questions on this, you will be having a lot of benefit. Then the last topic of the set is set comprehension, which is exactly the same which we have seen previously. For example, we want the square of the numbers from 1 to 10, but the number should be greater than 5. So what we can do, first we will write the for I in range 1 to 11, correct? So it will print out up to 10. Then we will apply in condition, so I is greater than 5, and then we will square that number here. So I squared, so here we will get the value as, you know, the squared set. So this was all about sets, and we have covered set very comprehensively, and we have covered so many questions, and I'll also attach some MCQs and the task with the mini projects, so then you will be good to go. So now we move to another super important concept, that is dictionary. So let's quickly deep dive in dictionaries. Dictionary in Python is a collection of keys and values used to store data values like a map, which unlike other data types which holds only a single value as an element. For example, we have an integer, so a equals to 1 is holding only one element. Again, in list we have the elements like 1 2 3 and all are single elements, correct? In tuples also same, and in sets also same, right? But in dictionary we can hold multiple values. And again, in some languages it is known as map or associative arrays. So let's understand how it works. So we can represent a dictionary with curly braces. In sets also it is same, curly braces. correct? The only difference is in this we have only single value as an element, but in dictionary we can hold multiple values. So let's say we have this dictionary, correct? In that, this is considered as one item, okay? And this is a key, and this is the value of that key. Again, Google is the key, and this price is the value of that key. And similarly, it goes on. So we have 1, 2, 3, and 4. We have 4 items here, or we can say we have 4 key value pair in this dictionary. Now let's see some characteristics of dictionary. So dictionaries are mutable, like dictionary and sets. Same like sets. In dictionary also there is no meaning of indexing because these are unordered. Again, keys can't be duplicated. Means we cannot have another key with the same name Apple. Again, keys can't be mutable items. Means at the place of this key, we cannot have a list or a set or any other mutable item, right? So if you remember these 4 characteristics, I think you will not make any mistake. So again, dictionaries are mutable like sets or lists. Indexing has no meaning. Means dictionaries are also unordered. Keys can't be duplicated. Means you cannot have the same name in 2 keys. And again, keys can't be mutable items. You can have a tuple as the key, but not a list, right? So these are the 4 very important characteristics of dictionary. And now let me show you one empty dictionary, which is this. Unlike in set, it was like this, right? So don't get confused between the empty set and empty dictionary. And when we hold an item in the dictionary, we hold like this. For example, we have a stock named Apple, and the price of that stock is, let's say, 1, 2, 3, 4, correct? Then again a comma and the next key value pair. Let's say this is BTC, and the price of BTC is $65,000. So these are 2 key value pairs. This is key, this is value. Again, this is key, this is value. This is first pair, this is second pair. While in sets, we have like this. Let's say we have the Apple, then we have BTC, correct? You can differentiate easily, right? Okay, now we quickly move to the coding examples and see how dictionaries operate. So to create an empty dictionary, we have to write like this, the empty curly braces. And when you print this, I hit shift enter, you get an empty dictionary, right? Again, for the 1D dictionary, what you can do, you can write a key and value. Again, second key and second value, third key, third value, and fourth value. So when you print these, shift enter, you can see that we have 4 key value pairs here. So here we have seen that these are the single key and single value, but we can also have multiple keys. So here at the place of a key, we have a tuple which consists of 3 elements. So when we hit shift enter, we get the value like this. As we have already seen that we cannot have a mutable item as a key. So here tuples are immutable, right? These cannot be changed. So we can have a tuple as the key. Then we proceed and take some example of 2D dictionary. So similarly, like a list and tuples, we can have 2D dictionary also. In 2D dictionary, what happens? We have a dictionary inside a dictionary. So if there are 2 opening and curly braces, we can also identify that this is a dictionary. So you can see here that in the outer dictionary, we have 4 keys: Apple, Google, Tesla, and Microsoft. So here we can see that the value of the key Apple is another dictionary, correct? And which has the 2 key value pairs, a price and volume. Similarly, same goes for Google, Tesla, Microsoft. So when we print this stock data, and let's print it here. And here you can see that we have the 2D dictionary output, which has the 4 keys: Apple, Google, Tesla, Microsoft, and the value of those keys is another dictionary, which consists the data of price and volume. Now we can also create dictionary with the dict function, same like the previously we have seen the type conversion. So for example, we have a list of tuples. So this outer is list. Inside we have 2 items as tuples, correct? And inside the tuple we have the strings as item of the tuple. So if we want to convert this list of tuples to a dictionary, we have to use the function dictionary, and when we print it out, you can see that we have a key value. Stock is the key and apple is the value. The price is the key and this float is the value. And again, both the key and value can also be the same. No problem with that. So that's how we can convert a list to a dictionary. And when we have two keys as the same value, see here, the name is Kuldeep and again the name is Singh. Let's hit shift enter, and what it will do, it will update the key. So it will take the last occurrence. Then we have the mutable items as key. So we have seen in the characteristics that keys can't be mutable items, correct? So for example, if I store here, like if I have a list, right? So list is mutable, right? When I hit shift enter and print D6, it will throw an error, unhashable type list. But if I just convert this list to a tuple, correct? Okay, I have to remove this also, or as type conversion we have seen, let's utilize that here. So tuple, and you can see that we have the output without any error. So this is how you can convert sometime the list to a tuple in order to avoid the mistakes, the errors. Now we see the example of accessing items from a dictionary. So what you can do, we have a dictionary with the 3 key value pairs, and if you want to access the value of the apple, so you have to write stock data, then you will write the key, right? So when you hit enter, the value of that key will be printed out. And similarly, if you want the Google here, so you can write Google and you will get the value of the Google key. Then for example, if you want to add another key value pair in this dictionary, so what you can do, you can just write another key and you can assign the value to that. And when you hit shift enter, you will get the output as updated dictionary. So you can see that we have another key value pair, Microsoft, as the value 299.35. Then similarly, you can also remove the key value pair. So here, let's say we have this dictionary and you want to remove the Tesla. So you can use the pop function here. So when you hit shift enter, and you can see that the pop has been removed. So in pop, you have to give the value. And similarly, if you perform like a stock data dot pop item, so, and when you hit shift enter, and okay, now when you print it, you will see that you have only one key value pair, because in pop item, it randomly removes any key value pair from the dictionary, right? And then we have the delete function. So let's say stock data, let us just comment it out again. So we have, okay, comment, okay. Now we have the complete dictionary. So we will use the delete function here. So delete stock data, and here you can give the key name, right? So let's say I want to remove Google from here. So when I do that and when I hit shift enter, you can see that Google has been removed, right? Similarly, we have clear, and this is also very clear that clear just clears the dictionary, right? So for example, if you use like clear and then you print it again, so you will get an empty dictionary. So that's how we remove key value pair from a dictionary. Now we move to the next part, which is editing key value pair. So if you want to update the value, let me comment these out. So if you want to update the value of any key, let's say we have the Apple 145.09 and you want to update it to 150. So you can just hit shift enter. Let me first run this cell, and when I hit shift enter, you can see that the value of Apple has been changed. So this is how you can update the value of any key in a dictionary. Now we have dictionary operations. These are also exactly the same which we have done previously. So let me copy and paste this here. So okay, let me copy and paste it here, and okay. So in membership, we have in and not in. So if I print that Google in stock data, so we have Google. So when we hit shift enter, it will give us true. But if I just change the value to any other, and when I hit shift enter, it will give me the false value. So it's same, right? there is no difference in that. Similarly, for the iteration, if you want to print all the items, what you can do, you can write for I in stock data, and here you have to write items, correct? Then you can print I, then you can print I. So when you hit shift and you will get all the keys and values. But what if you only wanted the values? So you can do like this, you will get only values, and for only keys you can write like this, so you'll get only keys. So that's how this works. And you can also use get. So instead of like writing sometimes stock data apple to get the value of this, you can also use the get function to get the value. So for example, if I run this one, I'll get the value of apple, correct? But not found is not existing in this, so it will not give us the value. And similarly, when I want to print out the not found when the key is not existing, what I can do, let's say I'll just write AYPL, so it is not in this dictionary. So when I hit shift enter, it will print out not found. And so this is how you can use the get function to print any message when the key is not existing in the dictionary. Now we have the functions of dictionary. So these are also exactly the same we have already studied. So let's take the same example, and here I print this. So if I check the len of this stock, so len and stock, so it will output the number of key value pairs in the dictionary. So it has 3 key value pairs, correct? 1, 2, 3. And if I apply the sorted here, so sorted, and when I hit shift enter, it will give me Apple, Google and Tesla. Of course, if I give any integer here, then it will get confused and it will throw an error. So while applying sorted, it has to be a single data type. It may be an integer or it may be a string. So let's change it to again Apple. Then we have the items, keys and values. We have already seen this, but again let me show here. So if I write stock items and items, so it will print out both the keys and values. Okay, so when I hit shift enter, it will give me the whole dictionary. But if I wanted only the keys here, so I'll write key and hit shift enter, so it will print out only the keys. And similarly for the values, you can write only the values and you will get the value of those keys. That's how it works. Now we have update. So for update, what you can do, if you wanted to add multiple key value pairs, so in that way you can use this update. So for example, I will write like stock data dot update, and inside that I'll pass a dictionary, right? And when I hit shift enter, nothing will be printed out, means something has done permanently. So now when I print stock data, you can see that we have Apple, Google, Tesla. But as we have seen the property that the keys cannot be same, so it will ignore the duplicate keys. So if I change this to like the small something, then when I hit shift enter, we can see that we have 6 key value pairs. So this is how you can use the update function to add multiple key value pairs. Now we have the dictionary comprehension. So that also works exactly the same like we have seen previously. So for example, it says print first 10 numbers and their squares. So what you can do, like in list, we will first display the dictionary sign, so that is curly braces. Then for I in range 1 to 11, right? Exactly same. Now we need the numbers and their square, so there is no condition, right? So what we can do, I and I square, right? So if I hit shift enter here, you will see that we have a dictionary with the number and the square 2, 4, 3, 9 and 10, 10. So this is how you can use the dictionary comprehension. Now we want to perform the dictionary comprehension with the existing dictionary. So let's say we have this dictionary, and here what we will do, for symbol and price, so symbol will be this and price will be this, correct? In stock data dot items, what it will do, it will multiply the price by 1.05. So when we hit shift enter, we get these values. So you will be using this a lot in your algo trading endeavor. Then we can also use the dictionary comprehension with the zip function. Now for example, we have these two lists, one with the keys and another with the values, and we want to combine this to a single dictionary, right, with the keys and values. So we can use the dictionary comprehension here. So first we will run the zip function, so it will give us an zip object, right? Then we have symbol and price list. So what it will do, it will combine both these and it will print out a dictionary. So you can see here. And what if when we have a if condition, so we only want the values in that the price is greater than 1000. So here only Google has the price more than 1000. So when we hit shift enter, we will get this, right? Only Google key value pair. Now we have nested dictionary comprehension. So here we have three lists: symbols, dates, and prices. So we are applying the first dictionary comprehension here, and then this whole dictionary comprehension becomes the expression for the second nested dictionary comprehension. So let's understand it in chunks. So what we can do, I'll just comment it out and let me show you. For example, we write historical prices, then we will create a dictionary, empty dictionary, then we will write the simple for loop, which we write for list and tuples, everything, right? So like for, let's say, J and date in enumerate in dates. So we will apply an enumerate on dates. So this enumerate will return a counter, right? So then I'll print the prices and then J, and here we can give the date, right, which was the enumerate counter. So when we print this historical prices, we get this dictionary, right, with the date and the prices. Next, we make this dictionary comprehension as another expression for this one. So here what we can do, we will write another dictionary symbol here, okay, and then we will apply again the comprehension. So for now I and symbol in again in enumerate, which will return a counter and symbols, right, in symbol, and here I want to print the symbol. So and I can write a colon. So now when I hit shift enter, we will get the value as this, the symbol name and the date and the prices. Again symbol name, date and prices. This is how we can use the nested comprehension. And still, if you are facing any issue, you can let me know, and definitely we can have another supplementary session for this nested comprehension or any other topic you are facing issues. So with that being said, we are done with the dictionaries, and now it's your duty to attempt the multiple choice questions and the task. In next session, we will start with the functions. So until then, see you, take care, bye bye, have a nice day.